Okay. Well, thank you very much. Thank you very much, Sam. I'll get started and let me just put the timer. So, hi everyone. Thanks for having me at PNSQC. This is my second time here, and I started this presentation in the night, so I was a bit grumpy, but the notes are more or less the same. So we're going to show why we should do mutation testing, say what we did in the beginning, and then where we reached. And then we're going to see what is mutational testing. Um, so basically, let's start with who I'm, right? And why am I giving you the speech? So I've been too long in the industry. I've been 18 as a QE, and now it's 11 as Adobe as a QE architect. I really like complex problems and cross-team technology. I think my grail is to start thinking as programming as literature and imagine something that has not been said through programming. As I said, this is my second time here. What I'm presenting is a follow-up of what I did. It's the research that I did, what the feedback I got, and putting this in place. I felt it matured, and I wanted to share this with you. Um, so, in a nutshell, what I'm trying to present here is a new vision, or at least my current vision of what a scenario could be. And a scenario in my vision and what I'm trying to present here would work as a template. It's not a very specific thing that we should follow blindly. And it should adapt to what we're expecting from it in depending on the context. This is what I will be showing here. And what I'm hoping to show is that we can ask so much more from a scenario, and a test should go more than just a scenario. It could be much bigger than that. So let's start from the beginning and a lot of why I got here. Originally, I wanted to automate software upgrades. Uh, it was extremely hard in the companies I was working at, even at Adobe, and I wanted to automate it. Traditionally, a lot of the approaches are that you fill a database with data, you start the upgrade process and see if it's working. Or you upgrade a system and you run your tests. These are fairly good systems. At Adobe, while I got there, they were doing some interesting stuff, and they were doing some scenario working, doing some steps, upgrading the system, and then continuing the story. And I thought that was very neat, but it was very hard. And looking at that, we saw that there were a lot of problems with these approaches. And I highlighted two big problems, and one was data. And it is that data, the way data is managed may change from one version to the other. And it's not always easy to follow this. And maintaining a database for multiple versions is a very complex thing. And we had to enrich data related to scenarios, and that was very hard, especially in upgrade systems. And the other problem, and it's a time problem, is that uh, we were, and that's what we were trying to solve manually, is that a lot of scenarios and testing scenarios are influenced by unit testing, and they do things in an atomic fashion. And it seemed to me that this is not how our product was used, at least in this case. And I think in reality, people don't do things in one go, A, B, C, D, search things, put them in the boss basket and check out. It doesn't work like that. People think about things, they take time. And in between these steps, things will happen. Upgrades could happen. You don't have any guarantee. And it could be in between steps 1 and 2 or between 2 and 3. We don't know. Not only that, there are other peoples in the same people in the same process. They're also doing things, and they're at different stages of their workflow or their process. And you have no way of predicting where, at what point people are when something happens. So we needed to solve this problem if we wanted to automate it. Even manual testing solved one case, but it could not solve all of these cases. It would not be scalable.
That was the other thing. So say I don't like.
All right. Okay. Uh, so what we did was we solved this by introducing some kind of a framework, which we called phase testing at the time, which was the precursor to what I'm going to present. And I think presenting it will help you understand how we're solving the problems for mutation testing. Also, for your information, this was something I presented at PSQC. It was the first presentation. It was an early version of that, and this is the follow-up. So some of it are things that I've slightly touched. So for the phase testing, we put some requirements, and that was that we needed to solve the problems I just spoke about, but we didn't want to introduce new tests. We didn't want to say that I want a dedicated test just for upgrades, because they're the same scenarios. There's the same stories we're trying to do. We're doing the same actions. It doesn't matter if it's an upgrade or not. So we wanted to leverage the scenarios and the tests we had. And we introduced something called phase tests. And phase tests are tests that are interruptible. And it means that the scenario can be interrupted in between. There are normal scenarios that are executed on a day-to-day basis, even when you're not upgrading. But when you decide to do an upgrade test, you could interrupt them at any point you like. So this was very important. Then we introduced a notion of shuffling, meaning that we should be able to re-execute the scenario with all of the possible interruption points. And that is something which is very important that we will speak further on. It means that the scenario will be executed and we will simulate the different users who are at different stages in their workflow to see how would the upgrade affect them. So we felt this was very important. There was a context which was central to a workflow for a process for a specific interruption. We called these shuffle groups. Basically, they could share information between these. So they were completely unique scenarios. It's just that they're interrupted and then they carry on after the upgrade where they left off. With this, we needed to also manage a context. And that meant that even this helped us manage the interruptions, manage the data. So we kept the context even though we stopped everything. And that was, for example, in the shopping basket example, you're searching for an item, you store the item ID, for example, in the cache. But when you put it in your basket, you're fetching that information. Things like these. These things were stored in a cache and then in a harder cache later. But this is a mechanism we needed to introduce. And finally, to be able to make scenarios interruptible, we had to create clear boundaries between the steps in a scenario and make sure that they're easily stopped. And we had to also, this was also important to identify dependencies, to clarify if a step, what information does it need to continue, and what kind of information it's generating for the following steps. And these are very important notions that all of the following things I will be speaking about will be dealt with these. Okay. So this has gone up. This is what we're talking about. This is 2 years ago when I spoke at PNSQC, and it is something which is in production. We've used this to not only do our regular upgrade tests, we've done it for a lot of different use cases like database migrations, making sure that there are no problems, uh, migrations between product families, which are not necessarily the same product, but they're the same scenarios, user stories. And this has allowed us to make sure we have a certain level of confidence that the migration or change, the system change works. However, all good ideas need to evolve, and this is what I call we mutated. And we learned a lot of things from phase tests. Presenting things at conferences like this gave us a lot of feedback, and we started thinking, what could we do more from what we can we go beyond upgrades? We've done migrations, but it's fairly similar. Can we use this notation, this kind of language we sort of introduced, to do other stories, tell other stories? And how far can we go? And the answer is much further. And I covered a very small part in my previous presentation, but here we're going to go actually 3 times more. And we identified that scenarios can mutate. As I said, the idea is that scenarios should be able to mutate. They should be able to adapt themselves to the problems we're trying to solve, the problems we want to test. And by giving this some thought, we sort of said, okay, scenarios should be able to mutate in different ways. We can switch different types of data. The scenario can modify itself in 3 different families. And a lot of this is generalization of the phase test framework that we did before. And the first one is data. Data mutation. And data mutation is something that a lot of us already do. And the moment you're not hard coding your test data, uh, you will be doing some form of a data mutation. So this is not rocket science. This is just a generalization of how testing could go. Frameworks, tools like Faker would usually create you fake test data in different languages, and that's a data mutation for me. The main thing is we extract test data from the scenario. This is very important. Uh, so let me switch over and do a quick demo. And this is, I hope you can see my screen. Can everybody see my screen?
We still see the presentation.
Okay, let me see. New share. Wait a second. I'll just do another share. And there, share screen. And I will share OJ.
Yep, we can see your IDE.
Wonderful.
Yeah.
Great. So this is a typical, this is written in Java for your information. The scenario we're talking about, the way we designed it is the scenario is the class, the methods are the steps. And this is how we do our phase test, but this is the new family. And in this scenario, we have 4 steps. One is we log in to the site. The other one is we search for a product. The next step is we add the product to our cart and we check out. So this is the scenario. What I'm going to do now is I'm going to run the scenario as a normal test. And in this case, it will run each step in order and execute it as if it's one test. And in this case, we get an execution. The scenario is called the shopping cart demo, and we've just executed it as one go. This is how it will be executed on a day-to-day basis. It's a normal scenario. Now, let's go back to the presentation. Are we seeing my presentation again?
Just the IDE.
Oh, let me, I should have played with this more. So let's go there. There.
Yep.
Are we good?
Yep.
Awesome. Thank you. So as I said, we had data mutations. Now let's look at event-based mutations. So the idea of event-based mutations came from phase tests, and we were saying, okay, how can we look at the upgrade? An upgrade is kind of an event, and it is an event to this event makes us react differently. So the scenario will work differently. And events could be a lot of different types. A lot of them are planned, like what we were trying to solve, like upgrades, migrations, but a lot of them are unplanned as well. Some are network problems, system crashes. These are unplanned events. We want to make sure that the scenario works as before, we're robust, resilient. And looking at this, we generalize this in two categories of events, interruptive events, and interruptive events is what I told you about phase tests, that they're just interrupted, or non-interruptive events where like chaos testing, events that happen while you're running and you should continue as before without any interruptions. And interruptive events, as I said, we stop everything you're doing, you do the upgrade, and you continue. Migrations are typical cases of these. In some cases, and in the problem we were solving, the problems I've solved, a lot of them were upgrades. We had to stop everything. This is not all upgrades. So you know, a lot of upgrades happen live. And one of the challenges, as I said previous, is how to continue after the interruption. This was technically what we had to solve. And shuffling was something that we had to use. So we took the same scenario, we executed the first three steps, then we execute the first two steps, and then we execute the first step. These are executed like different scenarios, but we call it a shuffle group to identify that where they're being interrupted. After the upgrade, we continue shuffle group 2-1, we just execute the last step. The shuffle group 1-2, we execute the two steps at the end, and then shuffle group 3 executes all steps. This way we know that the scenario, no matter when the upgrade happens, will continue. We can predict this. So let's go back to the demo and let's do the same thing. I'll stop sharing. I'll share my IDE and let's hope it's working.
Yep.
Awesome. Now let's go to the same thing. So in this case, I'm doing the same thing. So the first step, I will provision my system. I will start it as a producer phase. Historically, we called everything happening before the upgrade, before the event, producer phase, because we filled the database with data. So we called it producer. We will perform an upgrade, and then we run the consumer phase, which is what happens after. And it's because we consume the data that was filled in the database before the upgrade. And in this case, this is a demo that's open source. You can access this. What we're going to do is we're going to provision the system. It's a small bash. It's basically upgrading, filling the database, the local cache with information. Then we run the scenario in producer mode. And what we can see is that if you can see my screen in Chrome, that we've executed 3 times. And can see the scenario was executed with the first two steps first, then the first four steps, then the one step, and then three of the first steps.
Oh, unfortunately, we couldn't see that. We can only see your IDE.
Okay. Okay,
might-
for now.
Might help
uh,
to if you share your desktop. That might.
Oh, maybe it's a better idea. Let me see if I can do that. What desktop? Yeah, let's do that. It's probably better. Is this better?
Perfect. Yep.
Okay. So here we can see this is the test. The framework is based on test-ng, so we can see the report. And each of these we've run just two steps. The first one, the third one, the second one, we run it all the way. So here we're just filling the database. So we're making sure that when we're performing the upgrade, nothing bad happens. Then first step and then third. Okay, let's go back to the presentation. Are we good?
Yep. Perfect.
Okay. Now, so this was oh, sorry. I forgot. And now what we do is we upgrade the system. I forgot about that. And now I'll run the same thing, but now I'm just running the, the steps after the upgrade. And in this system, if we look at the results, we see now we have different ones. It's not always visible, but here you could see, here we've executed the scenario all the way from end to end. Here, well, it's similar from before, but we've only executed the three last steps. So, and this way we know that the scenarios have continued after. Okay. So let's go to non-interruptive events. And non-interruptive events is unexpected usually. One thing that we started talking about this, but ideally we thought about driverless cars, but then we realized it's very close to chaos testing, and this is what we're using it for now. Our goal with chaos testing in these with mutational testing is to make sure we have reproducible chaos. So predictable, it's chaotic, but we have a control. We're injecting things, so we're injecting events. So by definition, it's a little bit different from traditional chaos testing, but we're injecting events, so it's event-based. So, and in this case, it's non-interruptive events. Our challenges have been how do we wrap an event around a step or wrapping a scenario around an event? And in that case, we had the same notion of shuffling. And that meant that we can, for the same scenario, execute the event at different stages along the scenario. And if we go back to our demo, I'm going to provision the system. And now what I'm going to do, I've created an event called Gremlins. An event basically has a start, it waits until it's finished, and it has a cleanup step. In my scenario, what I've done is, just if we go back to the code, I'm logging in, I'm searching for a product, and I register the price. So when we're in a normal shopping system, we check that we buy something because probably the price is good, among other things. And then at the end, we have an assertion to see if the price is what we expected. Okay. What I'm going to inject here is gremlins who are really nice and they destroy the cache system for the database, the price database. We're just setting everything to -1. So this is a demo. I'm sure there are better examples. So what I'm going to do here is now that I've provisioned the system, let me just double check. I'm gonna run my same scenario, but in an asynchronous mode. But I'm injecting an event called gremlins who are basically gonna clean the database. If you remember, the scenario works very good as upgrade scenario. Now we're going to do it as a non-interruptive event. So I'm going to run this. And what will happen, thank God it's failing, it is not working. Let's look at our report. So here we see that it failed for steps, for shuffle groups 4 and 3, meaning it what happened was our gremlins, they log in, it doesn't matter. We look for a product. If the product has, but if the gremlins have changed the price before we look at the product, during while we're looking at the product, there's no problem because it's the same price. But in step 3 and 4, we're actually putting it in our basket and checking the price. And that's when the failure happens. And if you see here, we expected the price to be 47, but it's -1. We expected the price to be 47, and this one also to be 47, but it was not the right price. So this is how we can see this. And to solve this, what I'm going to do is I'm going to add an extra check. And basically, whenever I'm fetching the price, I'm resetting the cache. It's just a simple change. So I update on a regular basis the cache system for the prices. And when I run the same scenario a second time, you will see that the scenario will work because I'm constantly checking the prices. Okay, we're reaching the last part, and this is order mutations. And I'm very excited about this, honestly, because this is very new and I solved it technically this summer, almost in the last revision. So one thing we realize is if steps have dependencies and they have data they're dependent upon, and then they produce data on which other steps depend on, we can identify a logical dependency scheme between the steps, and we can identify a logical order between the steps. So let's go back to our scenario. In our scenario, log in, search product, put product in basket, and check out and pay. So login, when we log in, we store an authentication. We store a token in the system. So you're registered. When we search for a product, we find a product, we identify this product. So it's what we call produce, sorry. When we put product in the basket, we need to know the product. So we say consume. So we've consumed the product. When we put it in the basket, then the basket is known. It gets an identity. When we check out and pay, all elements should be in place. We should be authenticated. The product needs to be known because we want to check that the price is right. And the product needs to be in our basket. Okay. So with these dependencies, we can identify 3 permutations. Basically, the first permutation is what we saw, is the order we defined it. But the second permutation says that we don't need to do login to search for a product. I guess we all have looked for a product without logging in. Well, that seems fair. And putting a product in a basket, you don't necessarily need to be logged in. And with these things, with this dependency chaining, we're able to identify a set of logical permutations. And this allows us to run with a lot of different paths. And the same thing, as I said, is very similar We go here, we provision our system, and if we run permutation, it will run 3 permutations. Fortunately, I need to make this a bit more legible in the reports, but it has identified 3 permutations and it has followed them. This can be seen in the logs. And sorry, I'll probably do it on my next presentation, a better job at the reports. And that's really the end. So if I want you to have a takeaway with this is I'm trying to introduce the concept that a scenario should not be a scenario should be a multi-tool story that changes according to the scenario. It should be able to change in languages. It's the same story. It should work in languages which are not English. That's the data. It should be able to tell us what happens if we inject data. It should accept events, or it should be able to switch its order. And what I would like to do is to see, can we use scenarios to get to know our product better and try to be more curious about the product we test? So this is really what would be nice if people could go home with. But evolution, and this is more hypothetical and it's not here. The first thing is phase test was made for upgrades. We're moving to mutational, and we want to start writing scenarios which adapt in different cases. Phase test was really specific to upgrades. And we are moving towards the disappearance of a static notion of a scenario and move towards something more like intelligent steps, that in the future, maybe scenarios are just put together by some AI. I put the word in, that judging by the different dependencies can create scenarios for us that are valid. But this needs to be done. And it would be interesting. It would be some other research by myself or someone else. And now we still need to work on how do we work with the mapping and wrapping of events around a step, but we are working on that. We still need to do use cases and get maturity on this. And if people want to try this, please reach out to me. I would love to work with you and get some feedback. I'm doing these presentations just for feedback, really. So that's that. And I'd love to try to implement this in Cucumber, which I think has a very good step notion. So we're at the end. It took 3 minutes more than I planned. We have the code is in a branch right now, but it's phase tests. But at some point, I'll probably either create a new repository for this, but it is available. It's open source. Please feel free to play with it. The demo is also available. It's accessible to everyone. I've put the articles. So thank you very much. I hope it was understandable and I didn't go too fast. I really appreciate your time.